Now, we'll do him all the way to the bell. We may have to do school with him tomorrow, and then we will move on to solubility for the next 2 days. Do I know about what? The schedule for tomorrow is we're in here, I want to say about an hour and 5 minutes. Then second period's about the same. Third period is about a normal hour and a half. Fourth period's right at about an hour. I'm thinking we're in fourth period somewhere around 1 o'clock. And then 1 to 2 is fourth. And then from 2 to 3:30 is township. Okay, so you're in fourth period for 2.5 hours. If you did not buy a talent show ticket, you're in fourth period for 2.5 hours. I hope you really like fourth period. If you haven't, I would like run upstairs like in a super big hurry to see you as well today. Like, don't have to go as long as somebody like the city classes and like home tech. It would go, I'm sure there's some, there's what I go. Cut off, I'm certain there is one, yes. Well, as long as we start that thing like 2 quarters. There you go, I'm I'll send her anybody. I'll raise money for it. I wouldn't either. I mean, be thankful you're not in my fourth period. I made everybody in my fourth period happy. Yeah, I love it. I've harassed them till they're not the ones that make $1 per day. Anybody who couldn't afford one, I pay for. We were not staying here 2.5 hours. I hate to say that. We were not. You imagine 2.5 hours is more scared than me. I can't do anything. I mean, I least the one. Oh, God, that's the worst. I've had college sick. It's a good choice. Be entertaining or something else. It's just, what are the new clubs? There are 10 acts and 2 surprises. Okay. Or what? I have 2. I know one of the groups. Wait, in the group? Oh. So, wait, is that group that's the sports person? I mean, they may go up too, but I have not heard they are. I do know there is a group of males. And I'll leave it at that. No, I've not heard it either. I will not say more than that. Okay, I'm going to see King Play. Dear Lowry. I hear he's pretty good. Huh? And then he's also performing with Spear. No, sorry, with Jeremiah. He's in their club. All right, is everybody out here sketch up? So I can talk. All right, Joe, when you have it over there. Guys, I'm waiting on you. Wait, no, you know what? When I went to town, I'm not gonna what. Whenever someone went to town, so what should they say? They absolutely nothing, bowed and walked up. That's what I was going to do. Wait, the anticipation and then. Oh, and this is something great. Oh, wait. What is this now? No, it'd be better. It'd be better if you walk down and say, over the rain and stuff. You get a car, nobody gets a car. You get it, bro. You get $1. You get another $1.
Just kidding, I don't have $1 for you.
Are you there? All right, so everybody's caught up now. Now, we can calculate K. We talked about how to calculate K. But we never talked about what the number meant. So let's talk about what that means now. So, yesterday, we calculated a number, and it was, that's exactly the one I was going to use, 1.43 times 10 to the 10. Now, what does this number tell us? If K equals this number, all right, this means what? Okay, this means the forward reaction is fading. Well, that's great. Y'all can read what I wrote down. That's fabulous. But what does that actually say? Okay? It lies to the right. So, what reaction did we have yesterday when we had this number? Does anybody remember? Right? Do I need to put back together? H what? What's O2? H2O and Cl2. All right. So, if that's the reaction that we have, that means that in a container, we would have mostly this. All right. You have mostly these products. And you would have very little of this. Okay? So in a reaction, you would make mostly the product. It would go almost to completion, and you would get mostly water and chlorine. You would have a little bit of HCl and O2 maybe left over. But the vast majority of what you would make was water and chlorine. Remember when we did the salt lab? You all asked if you could eat the salt? What'd I tell you?
No, there might be extra.
There might be some unreacted HCl. All right? It was a K equation that was going to have a very high number. Most of what you made was salt. Very little baking soda or HCl would have been left. Almost all of it changed into salt, water, and carbon dioxide. But I wouldn't let you eat it, even though it had a really high K, because there could have been some what left over? HCl, okay? And no one wants to eat 6 molar HCl. Yes, the acid in your stomach is HCl, but the concentration is much, much lower, okay? It's possible. There's some people I wouldn't mind taking out, but y'all are there, okay? Now, if we have the flip side, for example, I didn't threaten y'all.
Wait,
all right? You can.
Can you take the rate up at the same time? Somebody's food and they die.
Suppose you have this. All right, 1.46 times 10 to the negative 4. All right, what does that say? That's right. You make very little product. Okay? You have mostly reaction. So let's say, just for a second, that we're in the business to make ammonia. If we want to make ammonia, and that's our K, are we going to make a lot of ammonia? No. If that's our K, we will not make much ammonia. We're going to have mostly what in the container? We're going to have mostly nitrogen and hydrogen. We're not going to have much ammonia. We're going to have mostly nitrogen and hydrogen. So, we need to find a way to make the ammonia. So Le Chatelier's principle that we're going to work with the rest of the class period is how we can shift this so we can make what we need. Okay? How can we shift the reaction to get it to go in the direction we need it to go? That's where we're going to spend the rest of the class period. Until after break. Okay? Until break.
Things like the three stresses from the colors.
Yes, sir.
That's what we're doing.
That's what we're doing. So what? We're going to talk about how to shift using temperature, concentration, and pressure to get it to shift. And you might need to combine temperature or pressure or concentration and pressure or something. You might not just have to change one. You might have to change more than one to get it to shift in the direction you want it to go. All right. Does everybody have what they want? All right. Let's talk for Chatelier. We don't need that. We need that. Yeah. Uh-huh. Yeah. All right. So, now, according to Le Chatelier, we can shift the system to that equilibrium. Okay? So, we're going to assume that we are already at equilibrium in these examples. Okay? So, somebody tell me what the Chatelier's principle says. Okay, that's not the Chatelier's principle.
If there's too much stress, you will automatically set it up with stress.
That's not bad. That's like, I'm not, yeah, that's your own words. That's not bad. That's pretty good. Anybody else say it? That's pretty good.
Is it like the whole thing is like stress?
That's not bad either. So that's pretty good. Now, for those of you who don't know what he said, all right, that's what he said. Again, you have already written this down one time. If a system is at equilibrium, then it is subjected to a stress. It will automatically readjust itself to minimize the stress. Now, that is the formal definition of Le Chatelier's principle. Daniela and Nada both gave nice interpretations in their own words of what Le Chatelier said. Simplify. If you can do that, don't write what's in blue. If you understand it, you can say it without having to write that. If you can't, you need to write it again. You need to be able to define Le Chatelier either in your own words or in his words. But you need to know Le Chatelier. I will be stunned speechless if he's not on your exam somewhere, either in interpreting or applying his principle. I would think somewhere in the 45 questions he will be there. Only 45. No, they're gonna make you do it without it.
Well, I didn't even get that fuck out. I was kidding. But all right.
And I gotta cover these in here too. And they're gonna make you do it without one.
Now I'm gonna fix it.
gonna give you a periodic table. Good God. How many times have I said that?
The first day we started.
For those who've listened, does anybody remember where I told you to be?
So I just remember you saying all right.
What was that? It's with the reference table. It's the middle page. So in your blue table, when you open it to the middle, it will be a giant periodic table. It will say 2 full pages. It'll be a book. In the very middle, you open it all the way, it will be 2 full pages of periodic table. Yeah. Sorry?
Okay, you and I don't know
What?
So, say we want to, like, you tell me that, like, I'm going to have to know, like, the reference tables are great, but, like, it's not like, okay, so like, there's, like, stuff and things that are not in the reference table, but I'm going to be attentive, like, if that's my job, like, I want to, like, write in what I do, so how do you like, up stuff, and, so why do you, like, have off the top of our head, probably a
lot of it you'll just know because you've done it so long.
Yeah, but
if you don't know, you just look it up.
No, it's not like that's not like what it's not like how you would actually like what I don't know how to vocalize this, but it's oh, but I think sometimes depending on I'm getting something like a physical process.
I can assure you, when I took this in college, nobody gave me reference tables. I had to know it off the top of my head. And up until the last probably 10 to 15 years, they can use reference tables. All this stuff that they use reference tables for, first 15 years I taught, I didn't know what to use. Oh, no, I was like a year, a lot of years ago. So when you had a metallic carbonate, you had to be able to tell me that it was metallic oxide plus carbon dioxide was the product. You didn't look at a reference table to get that. You had to be able to tell me that's what it was and then predict the product.
I get that was terrible, but those are
Wait, so they got them in my life. We're doing that other book. All right. All right. So, there are 3 ways we're going to shift equilibrium today. Pressure, concentration, and temperature. We've already done this. You know how to write it down once just hold it. Now, change in volume is another way we can change pressure. This is whose law? Is review. Very good. I'm worried about my alpaca farm. Y'all did good. I'm impressed. All right, that's Boyle's law. So, tell me how they're related.
Oh.
P who over there? P times V, directly or inversely? That's good. They're inversely proportional. So, if they're inversely proportional, that means what? That's right. So, if you read a question and it tells you that pressure increases, let me say this. If it tells you something like volume decreases, okay? If it says something like volume decreases in the question, you have to be able to interpret that into that's the same thing as what? That's right. You have to make sure that you understand that volume decreasing is the same thing as pressure increasing. They're going to expect you to be able to make that connection, okay? I don't think that'll be an issue. I think they'll probably say pressure increases. However, they could try to trick you by saying that the volume decreases. So I'm just putting that out there. Everybody okay with that? All right. Let's see if we can at least nail down part of Le Chatelier's today. All right. Everybody good? Okay. All right. We're going to do concentration first. All right. This is the part that people don't like about Le Chatelier. It's very rule-laden. There are 6 rules we got to do. We're going to do at least 2 today. I'm gonna do concentration first. The bold parts are the important parts. Okay? The other parts are the reasons. So I left the reasons in because lots of you like reasons and why, like Emma. Some of you just need the rules. Okay? The bold are the rules for those of you who are like, well, don't explain it. Just tell me the rules. Okay? The bold are the rules. The other parts are the why. So if you add a reactant or a product, a system in equilibrium will shift to try to get back to equilibrium. You disturbed it. It won't back there. Okay? It will shift to the side that will use up what you added. Got to get rid of it. You added stuff, disturbed the equilibrium, and wants it gone. So it will use it up. So it shifts to the opposite side that you added it to, so it can use it up. So if you add a reactant, what's the opposite side of the reactant? So it shifts to the product side. If you add a product, it shifts to the opposite side. What's the opposite side of the product? To the reactant side. You with me? Okay. The second rule. You can remove just as easily as you can add. So if you remove, and again, the bold is the rule, the non-bolded is the reason. There's one spot I can bold somewhere in here. All right, so if you remove a reactant or product, you shift to the same side. So if you remove a reactant or product, you will shift to the side to make more. If you remove it, you got to build back up what you took out to get back to equilibrium. Remember, these are at equilibrium. We just disturbed it. The Chatelier says if you disturb it, you work towards getting back to equilibrium. So I remove a reactant or a product. I've got to get back to equilibrium. I've got to make more. So I shift to the side I removed it from, which is essentially saying the same side. If you prefer that language. Side I removed it from is the same side. Yeah, build it back up for you to cover. Exactly. Exactly. All right? No, I can't. I'm sorry, I can't go do it. All right, everybody have the rules. Huh? Very powerful. I know, but I don't have one. All right, never have what they need. Are we there? We're too broke for that. That's a very good answer. Miss Curry would really approve of that. Now, if we look at that equation that's on there, write it down, and we're going to try those three questions. We're going to do those three things. Okay? Those are the three example questions we're going to do. We're going to fill it out.
That is in.
Yeah, N2 plus O2 yields NO2. They're all got it. Both my nephews get out of school today. Yeah, I said the same thing. But I don't, yeah. That's better. I'm in school for Thursday.
I know, that's fun.
Oh.
The thing is, I can't even not go to school Thursday because we can't even like do that. I got it. Like, I got it. I've been back there about 1:40, so that's an hour and 10 minutes. That's like, you got an hour to go home.
What are you talking about? I got sexual harassment training at 1 o'clock.
Oh.
Wait, just not one.
They're not gonna tell you anything.
Well, I feel like you would be like one of those people like walking down the street and a bumper would like come up to you and they think you would be back to like bump. And then you like, really good at it. I just like to see it like that.
All right. So, in my current mood, I think they'd probably walk away. So if we look at that equation, if I add oxygen, what's the rule?
The product will shift to the side. Oh, it shifts to the opposite side.
All right. It goes to the opposite side. Okay? Anytime it says add, it goes to the opposite side. So, what side is oxygen on? Okay, it's on the reactant side. So that means it has to go to the what side? It has to go to the product side. So that means it shifts right. Okay? Hold on. Now, if it shifts right, everything on this side increases in concentration, and everything on this side decreases in concentration. All right? So to review, you said, the rule said if we added, it did what? To the opposite side. So I wrote down opposite side because you said add, went to the opposite side. What side of this reaction is oxygen on? It's on the reactant side. So I wrote reactant. What side is it going to go to based on the rule? That's why I said reactant to product, because you said it went to the opposite side. So that means it shifted to which side? To the right. Okay, that's why I wrote shifts right. Now that means that whatever's on the right is going to increase in concentration, and whatever's on the left is going to decrease. Now, this right here, if you had said shift left, whatever's on the left is going to do what? Whatever's on the left side would have increased, and whatever's on the right would have done what? Decreased. So, let's say we remove nitrogen. If we remove, what's the rule? All right, stays on the same side. Let me write the rule down. Same side. All right, so what side is nitrogen on? On the reactant side. All right, so that means it shifts which way? Okay, going to shift left.
Pardon the interruption. Students who have signed up for the Lighthouse Club, that's 9th and 10th graders who signed up for the 9th Lighthouse Club and came to their assembly. Your club period will be in the auditorium today. If you are participating in off-campus activities, we ask that you still do that. So those that are with Mr. Al, please continue to do that. But all others who have signed up for Lighthouse, your club will be in the auditorium, those 9th and 10th graders today, and you will come down for their presentation in the DJ assembly.
All right. I'll leave your 9th and 10th grade.
Wait. Wait, what are we doing? I'm not. I don't.
Then you're supposed to go. All right, we can talk about it later. Moving on. So if it shifts left, what happens on the left side over here? That's right. Concentration increases. And what happens over here? Concentration decreases. All right. So this time, we're going to remove NO. And I'm going to ask you what happens to the concentration of oxygen. Okay? That's the question. What happens to the concentration of oxygen? That's what I want to know. Okay? So, how do we figure it out? What do we start with? If that's the question on the test. I want to know if I remove NO, what happens to the concentration of oxygen? Does it increase, decrease, does it go? How do we figure it out? All right, hold on. If you remove NO, what's the rule? Okay, remove NO. It has to go to the same side. All right, what's the same side as NO? Okay, to the right. Okay, to the right side. So, all right, so remove NO. Okay, so let's do a little bubble. So if it shifts right, change the colors here. What happens on the left side? Concentration decreases. Concentration over here does what if it shifts to the right? Increase. All right. Now, where is O2 in this reaction? It's over here. What side is the reactant? It's on the decrease side, right? So O2 decreases. You got to go through the whole process to figure that out. It's not a quick glance up, increase, decrease. You got to work at it. Okay? It takes a little thought process. I didn't you were going to tell me that.
Pointless. So pointless.
Let's try pressure. Maybe you'll like this one better. No. Okay. Try pressure.
You put 2 3s.
2 3s. Sure enough. All right. Let's try pressure. Keep your legs moved up. Everybody tells me concentration is the hardest. I don't know why it's talking over here. All right, so again, the bowl is the rule. The non-bowl is the reason why. So if we increase the pressure on a system at equilibrium, we're trying to get back to equilibrium. So the system will try to decrease the pressure to get back. So it has to shift to the side of fewer moles. So, which way will try to shift? It goes to the side of fewer moles. So if I decrease the pressure, it will shift to the side and bring the pressure back up. So it shifts to the side of more moles. Now, this is also the only one that can have no effect. Why can this one have no effect? Because how are we going to figure out the moles? Moles come from where? They don't come from the square root of the Y'all kill me with this. Y'all better start putting some donations My pack.
Already present the first day.
Oh, they chicken. So where do coefficients come from?
The balance equation.
Right. And balanced equations can have one on one side and one on the other side. The same number of moles, which is why this is the only one, it could actually have no effect. Okay, concentration and temperature are never going to have a no effect test, but pressure could have a no effect test.
So, Wilson is what?
The equilibrium. That answer is always equilibrium will shift. The reaction to equilibrium. For example, if you had 2 moles on the left and 2 moles on the right, would changes in the pressure have any effect on the equilibrium? No. Wrong. All right, does everybody have it? Are we there? Try, you got it? No. Say what now? Pressure is the only thing that can have no effect. Concentration and temperature will not have an answer of no effect. Huh? Yeah, I haven't hung it up or set it up yet. Huh? It's a screen with it. Like, not very good. Oh, it is. Yeah. Oh! I buy that. I might take it. Yeah, I'm packing, I need food. All right, everybody got it now? All right. So, there we have it. Plain old equation on ammonia again. That's where we're going to stop. God help us all. I know you're not, but we're going to try it anyway.
I know you're doing it.
Okay. Won't be the first time I heard your feelings go for one. It's Christmas season and all. What's the question?
Oh.
What is wrong with you? Alright, so if we look at the equation, what can you tell me about the number of moles? There are coefficients, that's good. How many are on the left? 4. Good. How many are on the right? Very good. So there's 4 moles, there's 2 moles. So, if I increase the pressure, that's the same as doing what to the volume? Decrease. Yes. Just saying in case you should see that. Okay? So, if I increase the pressure, it will shift in the direction of what, according to the trustee rule over here? The side of what? Didn't I say increase? Yeah. Whoops, wrong way. I said increase the pressure. I thought that's what I said. So we'll go to the side of fewer moles. Okay? So increase the pressure. The rule is fewer moles. So that means I do what? I shift what? I shift right. Now, let's just say that I ask something like, what happens to the concentration of hydrogen? Or what happens to the concentration of ammonia? Based on the fact that you said it shifts right, you should be able to answer that. If it shifts to the right, it doesn't matter if we're talking concentration or if we're talking pressure. Anytime you say it shifts to the right, whatever's on the right does what? And whatever's on the left does what? So, what's going to happen to my hydrogen, which is here on the, what's that? 0, right? So hydrogen is where? It's on the reactant side, so it's gonna do what? So it's gonna decrease. What's gonna happen to my ammonia, which is on the right side of the arrow? It's gonna increase. Now, we have to do this every single time we do what? We figure this out.
So we can just do this.
You can't just do that in your head. Okay? Now, no. I do it in my head. I don't write this down every time. I process this in my head. I'm just writing it for instructional purposes.
Oh, so we don't have to like.
After you do it a couple times, you can do it in your head yourself.
I just want to.
Okay? Tomorrow we'll do temperature. We'll practice it a little bit. And then we're going on solubility. Okay? Your homework tonight is to study these. Because we're not going to spend